January 1905. The Sierra Nevada crest lies under a pale morning sky. Cold air settles into the timber, motionless and dense. In the valleys below Donner Pass, pine forests stand silent. No wind disturbs the branches. The only sounds are distant and mechanical, the faint percussion of telegraph keys in wooden stations, the hiss of steam rising from locomotives being prepared for the climb over the mountains. The transcontinental corridor runs through this landscape like a thread pulled tight across granite and snow. Wooden snow sheds span miles of track, their roofs sloping steeply to shed winter loads. Trestles bridge ravines carved by centuries of runoff. The grades are severe, rising thousands of feet through switchbacks and tunnels blasted from stone. Sidings appear at intervals, allowing eastbound and westbound trains to pass on the single main line. Crews move through their routines. Section hands inspect track joints for frost heave. Firemen stoke coal into fireboxes, building pressure for the long push upward. Telegraph operators tap out train orders and weather reports. The work is ordinary, practiced, calibrated to the demands of winter in the high country. The snowpack from earlier storms lies compressed beneath the rails. Drifts fill the spaces between shed timbers. Ice clings to the underside of trestles where meltwater has frozen in shadow. The mountains are engineered for passage, but only just. Every structure, every mile of track, represents a negotiation with the terrain. There is no urgency in the air, no gathering wind. The sky holds a uniform gray, the kind that suggests more snow eventually, but not yet. Locomotives idle at sidings, waiting for clearance to proceed. Smoke rises vertically from their stacks, dissipating slowly in the still atmosphere. The corridor functions as it has through previous winters, narrow, vulnerable, but open. In the station houses, oil lamps burn against the dim light filtering through frosted windows. Stoves radiate heat into small rooms where dispatchers track train movements on chalkboards. The telegraph lines hum faintly with transmissions, carrying the business of a nation that depends on this single route through the mountains. This is the fragile normalcy of the Sierra in winter. The infrastructure holds. The trains move. The passes remain negotiable. Everything depends on the weather staying within known limits, on storms arriving and departing according to the patterns crews have learned to anticipate. For now, the mountains permit passage. The stillness is deceptive only in retrospect. The Sierra Nevada runs north-south for 400 miles, a barrier of granite rising abruptly from the Central Valley. The eastern slope drops sharply into Nevada. The western slope, longer and more gradual, channels Pacific moisture upward into zones where snow accumulates at rates that exceed most other ranges in North America. Near the crest, where the railroad crosses, elevations reach 7,000 feet. The terrain funnels wind through passes, creating conditions that amplify storms. By 1905, the infrastructure crossing this range had been in place for nearly 4 decades. The original route, constructed in the 1860s, had been modified repeatedly to address winter conditions. Miles of wooden snow sheds now covered the track, designed to protect trains from avalanches and drifting snow. These sheds were massive structures, their timbers cut from Sierra forests and assembled into continuous galleries that turned sections of the line into dark tunnels even in daylight. Snowplows of the era were wedge-shaped pusher plows, mounted on the front of locomotives. They could clear moderate drifts but stalled in deep, consolidated snow. Rotary plows, introduced in the 1880s, used a circular blade powered by a dedicated steam engine to cut through packed snowbanks and throw the snow to the side. These machines represented the best available technology, but they had limits. Drifts exceeding 10 feet could jam the rotaries. Ice and wet snow clogged the mechanisms. Operations required clear track ahead and sufficient steam pressure, both of which became uncertain in prolonged storms. Telegraph lines followed the rail corridor, strung on wooden poles alongside the track. These lines were the only means of communication between stations. When snow or ice brought down a pole, entire sections of the route went silent. There was no redundancy. Crews relied on line-of-sight observations and the arrival or non-arrival of scheduled trains to understand conditions. The meteorological setup in early January 1905 showed characteristics that would become significant. A strong low-pressure system was developing over the Pacific, drawing moisture from subtropical latitudes. Upper-level winds were aligned to push this moisture directly into the Sierra. Temperatures at crest elevations were forecast to remain well below freezing, ensuring that precipitation would fall as snow rather than rain. These were routine elements of winter weather in the range, but their combination and persistence would soon exceed routine thresholds. Towns along the route were small and isolated. Truckee, Blue Canyon, Emigrant Gap each depended entirely on the railroad for supplies, mail, and connection to the world beyond the mountains. Roads were impassable in winter. There were no alternative routes. If the railroad stopped, so did everything else. Warehouses held limited reserves. Coal for heating, food staples, lamp oil, all arrived by rail. The margin for disruption was narrow. The vulnerabilities were structural. Single-track operation meant that a blockage anywhere stopped traffic in both directions. Steep grades required helper engines, which had to be positioned and coordinated through telegraph orders. Cuts through rock or compacted snow became natural traps for drifting. Avalanche paths crossed the line in dozens of locations, and while some were protected by sheds, many were not. The system functioned under the assumption that storms would be manageable, that plows could keep ahead of accumulation, that breaks in the weather would allow recovery. It was an assumption about to be tested. The snow began lightly on the morning of January 15. Flakes descended through still air, small and dry, dusting the roofs of snow sheds and settling on the frozen surface of earlier snowpack. By midday the intensity increased. Visibility dropped to a few hundred yards. Treetops on the ridges above the track faded into a uniform white. The sound of the storm was minimal at first, just the soft accumulation of crystals on every horizontal surface. By evening the snowfall had become heavy. Visibility shrank to less than 100 feet. Locomotives climbing toward the summit moved slowly, their headlamps illuminating only the swirling snow immediately ahead. The hiss of steam engines, normally sharp and percussive, became muffled, absorbed by the thickness of the falling snow. Section crews reported accumulation rates of 2 inches per hour. Telegraph messages between stations noted delays as trains struggled to maintain speed through deepening drifts. The snow was light and powdery, the kind that wind could move easily once it began to blow. For the first 24 hours the air remained relatively calm, but accumulation was relentless. Track that had been cleared in the morning was buried by afternoon. Sidings filled in. Turnouts disappeared beneath smooth white surfaces. Crews worked continuously, shoveling entrances to snow sheds, clearing switches, keeping steam lines from freezing. By the second day, January 16, the wind arrived. It came from the southwest, driving across the open slopes and funneling through the passes. The new snow, unconsolidated and loose, began to drift. Within hours, cuts that had been passable were filled to the level of the shed roofs. The wind carved cornices on the ridges and deposited massive drifts in the lee of any obstruction. Visibility dropped to zero during gusts. Crews working outside retreated into sheds and station houses. Historical records from the storm document snowfall totals exceeding 10 feet in the first 3 days. Measurements were taken at several locations along the route. At Blue Canyon, observers recorded 12 feet. At Emigrant Gap, the depth reached 15 feet on level ground, with drifts measuring twice that in sheltered areas. The snow loading on structures became a concern. Shed roofs, designed to carry heavy loads, began to sag under the accumulation. Ice formed along the eaves where heat from passing locomotives had caused brief melting. Trains that had entered the mountain corridor before the storm's full intensity were now trapped. A westbound freight stalled in a cut east of Donner Summit, its rotary plow unable to move snow that had drifted and compacted into a solid mass. An eastbound passenger train halted at a siding, waiting for clearance that never came. Helper engines, positioned to assist trains over the steepest grades, sat idle as the track ahead disappeared. The telegraph network began to fail. Poles snapped under the weight of ice and snow. Lines went slack and then dead. Stations that had been in constant communication fell silent. Dispatchers sent final messages reporting conditions before their connections dropped. The isolation was immediate. Without telegraphic orders, train movements became impossible to coordinate. Crews waited, engines banked to conserve coal as the snow continued to fall without pause. There were no breaks in the storm, no clearing skies, no reduction in intensity. The Pacific moisture fed continuously into the mountains, and the temperatures remained cold enough to keep all precipitation frozen. The blizzard settled over the Sierra and stayed, burying the corridor beneath a depth of snow that exceeded the capacity of the infrastructure to manage. By January 18, the transcontinental line through the Sierra was completely shut down. No trains moved in either direction. The main line, the single thread of steel connecting California to the rest of the nation, lay buried beneath drifts that in places exceeded 20 feet. The corridor had closed. Locomotives stood motionless in snowbound cuts, their fires banked low to conserve fuel. Steam pressure dropped as coal supplies dwindled. Crews remained in the cabs and cabooses, burning whatever wood they could salvage to maintain minimal heat. Outside, the wind continued to drive snow into every depression, sculpting drifts that rose above the roofs of the snow sheds. The sound was constant, a low roar punctuated by sharper gusts that rattled loose boards and shook the timbers of the sheds. Rotary plows, the primary tool for clearing heavy snow, were deployed but quickly overwhelmed. The machines could cut through loose snow efficiently, but the storm had deposited snow faster than the plows could remove it. Drifts packed solid under their own weight and the pressure of wind. When a rotary attempted to bite into these compacted masses, the blades jammed. Steam engines driving the plows overheated. Gears stripped. Crews spent hours digging out stalled rotaries, only to have the track behind them fill in again within minutes. Helper engines, positioned at intervals to assist trains over steep grades, were now isolated at their sidings. Snowdrifts blocked the track ahead and behind. There was no way forward and no way back. The engines sat cold, their tenders half empty, their crews waiting for orders that could not be transmitted. The telegraph lines that connected these engines to dispatchers had failed days earlier. Wooden poles, coated in ice and burdened by wind-driven snow, had snapped in sequence, bringing the wires down across miles of route. At key locations, the infrastructure showed signs of strain. Snow sheds, designed to protect the track from avalanches, now bore loads that approached their structural limits. Timber beams creaked under the weight. Roofs sagged. In a few places, the snow pressed down so heavily that the shed's supporting posts began to shift, their bases compressing into the saturated ground beneath the snowpack. Engineers inspected what they could reach, but movement outside the sheds was nearly impossible. Turnouts and switches, critical for routing trains between the main line and sidings, were completely buried. Even if a train could move, there was no way to change its path. The mechanical interlocking systems that controlled these switches were frozen solid. Signal arms, which normally communicated track status to engineers, hung motionless, their lamps extinguished or obscured by snow. The operational complexity of the railroad, which depended on precise coordination of movements, had collapsed into simple immobility. Westbound trains stranded on the eastern approach to the summit carried passengers who had not expected a prolonged stop. The cars were heated by coal stoves, but fuel was limited. Food supplies, adequate for a journey of days, began to run low as the delay stretched into a week. Conductors rationed what remained. Water for drinking and for the locomotive's boilers had to be melted from snow. The work was constant and exhausting. Eastbound trains on the western slope faced similar conditions. Some had managed to retreat to lower elevations before the track became impassable, but others were caught in the high country. Crews maintained steam in the engines as long as coal lasted, knowing that once the fires went out, restarting in sub-zero temperatures would be nearly impossible. The isolation was total. There was no communication with the outside, no knowledge of when relief might come. The blizzard continued. Days merged into a continuous white roar. The mountains had absorbed the railroad, burying it beneath a snowpack that transformed the landscape into something unrecognizable. The corridor, engineered and maintained at great expense, had ceased to function. The west was cut off. The mountain towns went silent. Truckee, perched beside Donner Lake at an elevation of 6,000 feet, had not received a supply train in 5 days. The general stores rationed flour and canned goods. Coal bins in homes and hotels dropped toward empty. Residents burned furniture and fence posts to keep stoves lit. The snow on the main street stood higher than the ground floor windows. Paths between buildings were narrow trenches, their walls vertical and unstable. In Blue Canyon, 20 miles west of the summit, the situation was similar. The town depended entirely on the railroad for connection to the world beyond the mountains. With the trains stopped, mail ceased. Telegraph lines were down. There was no way to send or receive information. Residents gathered what news they could from railroad employees stranded in the depot, but the employees knew little more than anyone else. The storm had severed all links. The silence was pervasive. Wind moved through the snow-laden pines with a muffled sound, more felt than heard. Rooftops, burdened by accumulated snow, settled with occasional groans as timbers adjusted to the load. In some buildings, the snow reached the eaves, creating the effect of structures half buried, their upper windows the only indication of their original height. Lamps glowed faintly through frosted glass after dark, small points of light in an otherwise featureless white expanse. Section houses, where track maintenance crews lived during the winter months, were scattered along the route at intervals of several miles. These were small structures, built for function rather than comfort. Each housed a crew of 5 to 10 men responsible for keeping a section of track clear and operational. Now, with the line shut down and the storm still raging, the crews were isolated in place. Supplies of food and fuel, calculated to last between resupply trains, were running low. There was no way to request more and no way to leave. Avalanches began to occur as the snowpack deepened and destabilized. On the slopes above the railroad, layers of new snow accumulated faster than they could bond to the older, harder layers beneath. The result was a condition of high instability. When slopes released, the snow moved with enough force to snap mature trees and scour paths down to bare rock or soil. Several avalanches crossed the railroad in areas not protected by snow sheds. These were documented in later reports. Slides that deposited debris fields hundreds of feet wide and dozens of feet deep across the track. One such avalanche occurred near Emigrant Gap, where a steep slope funneled directly toward the line. The slide carried timber, boulders, and compacted snow down onto the track, burying it beneath a mass that would take weeks to clear. No trains were in the path at the time, but the event illustrated the scale of forces at work. The mountains, loaded with more snow than the terrain could hold, were redistributing that load through natural processes that paid no attention to the infrastructure below. In the larger towns, some residents attempted to move on foot to lower elevations. The attempts were largely unsuccessful. The snow was too deep for travel without skis or snowshoes, and even with those, progress was slow and exhausting. Drifts filled valleys and obscured trails. Whiteout conditions made navigation impossible. Those who tried turned back after a few miles, realizing the effort was futile. The mountains had become impassable on foot as well as by rail. Shelters along the route, depots, section houses, small hotels built to serve railroad passengers, remained occupied but increasingly precarious. Fuel supplies dwindled. Food stores dropped to basics: beans, rice, dried meat. Water came from melted snow. The work of melting was time-consuming, requiring constant attention to stoves. Heat was minimal. Occupants wore all the clothing they had, layering everything available to conserve body warmth. The storm showed no sign of weakening. Snow continued to fall, day after day, accumulating on top of what had already fallen. The depth at the crest exceeded 20 feet on level ground. In drifted areas, measurements were meaningless. The snow simply filled whatever space existed until it could hold no more. The landscape lost definition. Ridges and valleys blended into continuous white. Only the dark vertical lines of tree trunks and the occasional roofline broke the monotony. This was isolation in its most literal sense. Separation from supply, communication, movement. The high country had closed around those within it, and there was nothing to do but wait. The work of reopening the line began even as the storm continued. Crews that could move did so, focusing first on clearing access to stranded trains and critical junctions. The process was methodical and exhausting. Snow had to be removed not just from the track but from the entire corridor, including turnouts, sidings, and the approaches to snow sheds. Rotary plows were brought forward wherever track allowed. These machines, each powered by its own steam engine and pushed by one or more locomotives, were the primary tools for cutting through deep snow. The rotary's circular blade, mounted vertically at the front of the machine, spun at high speed, biting into the snowbank and throwing the cut snow out through a chute to the side. In ideal conditions, a rotary could clear track at walking speed. In the conditions that existed after the storm, progress was measured in feet per hour. The snow had compacted under its own weight and the pressure of wind. In some places it had the consistency of concrete. The rotary blades, designed for lighter, looser snow, struggled. Engineers throttled the steam engines to maximum output, but the machines still bogged down. When a rotary stalled, crews had to shovel out around the blade by hand, a process that could take hours. The freed machine would move forward a few yards before stalling again. Inside the snow sheds, the situation was different but no less challenging. Drifts had filled the sheds through any opening, broken boards, gaps at the ends, ventilation ports. The snow inside was protected from wind and sun, remaining light and loose. Crews shoveled from the shed entrances inward, clearing a path wide enough for a locomotive. The work was done in near-total darkness, lit only by lanterns. The sound was rhythmic and metallic. The scrape of shovels against wooden planking, the clang of tools against steel rails, the heavy breathing of men working in confined, unheated spaces. Telegraph crews worked to restore communication. Poles had to be located beneath the snow, then excavated and reset. Lines that had snapped needed to be spliced and restrung. The work required climbing poles in sub-zero temperatures, handling wire with numbed fingers, and coordinating repairs across miles of route without the benefit of the telegraph itself. Crews moved on foot or on skis, carrying tools and replacement wire, working section by section to bring the system back online. Steam boilers in the locomotives required constant attention. Coal, when it could be obtained, was fed continuously to maintain pressure. Water, drawn from melted snow or from lineside tanks where they were accessible, had to be kept from freezing in the lines. Engineers monitored gauges and adjusted valves, nursing the machines through conditions they were barely designed to handle. When steam pressure dropped too low, the engine lost the power needed to move the rotary plow or even to move itself. Recovery required hours of stoking and waiting. Track inspections revealed damage. Rails had bent under the weight of snow and ice. Ties had shifted or cracked. In places where the snowpack had compressed unevenly, the track gauge had narrowed, creating a risk of derailment. Crews worked to correct these issues as they found them, but the process was slow. Each repair required tools, materials, and time, all in short supply. Snow depths presented engineering challenges that exceeded anything in the operational manuals. At the summit, drifts measured 30 feet. The snow sheds, their roofs steeply pitched to shed accumulation, had held, but just barely. Inspection revealed cracks in support timbers and shifts in post alignment. Engineers calculated loads and made temporary reinforcements where possible, knowing that a full assessment and repair would have to wait until the snow melted. The clearing operations moved forward in both directions from points where equipment and crews could be concentrated. From the west, plows worked uphill toward the summit. From the east, another effort pushed westward. Progress was uneven. Some sections cleared in a day, others took a week. The variability depended on drift depth, snow consistency, available equipment, and crew endurance. As sections of track reopened, the first trains to move were those carrying coal, food, and supplies to stranded locations. These were the priorities. Mail followed. Passengers came last. The railroad operated under emergency protocols, with all decisions focused on restoring basic function. The complexity of scheduled operations, passenger trains timed to connect with steamships, freight movements coordinated across multiple railroads, had been reduced to the simple goal of getting trains through the mountains again. The work continued for weeks. By early February, the storm had weakened. Snowfall became intermittent, then stopped. Clouds lifted from the crest. For the first time in more than 2 weeks, sunlight reached the mountains. The light was harsh and flat, reflecting off a snowpack that extended without interruption across the entire visible landscape. Visibility returned gradually. Ridges that had been obscured emerged as dark lines against the white. Telegraph poles, though still standing, protruded from the snow at odd angles, their lines slack or broken. Roofs of structures in the towns appeared as isolated patches of dark shingle or metal, the rest of the buildings submerged. The scale of accumulation became clear only when compared to known landmarks. A 2-story building in Truckee showed only its upper windows. In Blue Canyon, snow reached to the second-floor balconies of the Depot Hotel. Sculpted drifts marked the paths of wind. Cornices hung from ridge crests, some extending 20 feet beyond the rock. In sheltered valleys, the snow lay smooth and deep, a uniform surface broken only by the occasional tree. On exposed slopes, wind had scoured the snow down to older, harder layers, creating a rippled texture like frozen waves. Crews continued clearing the corridor. With the storm ended, progress accelerated, but the volume of snow remained immense. Rotary plows worked continuously, cutting through drifts and throwing snow off to the sides. In many places, the plowed snow created walls higher than the locomotives themselves. Trains moved through these corridors slowly, their passage marked by the plumes of steam and smoke rising into the clear, cold air. Telegraph communication was restored section by section. As lines came back online, dispatchers re-established coordination between stations. Train orders began to flow again. The system, dormant for weeks, resumed its function. Schedules were meaningless for the moment. Operations focused on moving stalled trains out of the mountains and bringing in delayed freight. The backlog was enormous. Repairs to infrastructure began as soon as access allowed. Timber crews assessed the snow sheds, marking damaged beams and posts for replacement. Track gangs moved along the line, correcting gauge issues and replacing broken rails. Telegraph crews spliced breaks and reset poles. The work would continue for months, extending well past the end of winter. In the towns, life began to normalize. Supply trains arrived, bringing coal, food, and mail. Residents dug out their homes and businesses. Paths widened into streets. The snow would remain until spring, but the isolation had ended. Communication with the world beyond the mountains was restored. The long-term consequences of the storm were structural. Railroad engineers reviewed the performance of the snow sheds and recommended reinforcements. Additional sheds were proposed for sections that had proven vulnerable. Rotary plow designs were evaluated. Modifications were made to improve performance in compacted snow. Operational procedures were revised to account for the possibility of prolonged closures. The blizzard of January 1905 entered the record as one of the most severe winter storms to affect the Sierra Nevada in the era of transcontinental railroading. Snowfall totals at the summit approached 40 feet over the course of the storm. The closure of the line lasted more than 3 weeks. The economic impact was significant: freight delayed, passengers stranded, mail suspended. But the human cost had been limited. There were no fatalities directly attributed to the storm. Crews, passengers, and residents had endured the isolation and emerged when the mountains reopened. By March, the corridor had returned to routine operation. Trains climbed the grades and descended the western slope on schedule. Telegraph traffic flowed continuously. The snow sheds stood, weathered but intact. The infrastructure had survived. The Sierra, having demonstrated its capacity to close the route, settled back into the rhythm of a mountain winter. The storm was memory now, recorded in the logs of dispatchers and the measurements of weather observers. The line remained open, marked by the event, prepared a degree more for the next test the mountains would impose.